Today's the day we take these equations up to the next level. So grab your Pythagorean identities and we'll get started. So there's really not many changes from the time we did this a week ago or 2 weeks ago. What's going to change are the directions. So now the domain will be assigned to that specific problem. So you're going to change your domain in almost every problem. Also, you're going to start using the Pythagorean identities in some, but not all, of the problems. So if it tells you no calculator, that means it's usually going to be a unit circle value. Sometimes they don't tell you that, though. So you just kind of have to know, oh, that's on the unit circle. I can't have a decimal. And that means radians also. So that's where the decimal will come in. So here we're going to divide by radical 3, obviously. Now, if you need to, you can rationalize that, but if you don't need to, then don't. This is your interpretation. This is you figuring out the unit circle. So if we fix that, that would be radical 3 over 3. Or you could just leave it 1 over radical 3. So as you know, my little trick, there's 2 radical 3's in it, then we know it's pi over 6. And then, of course, figure out where else it's positive, down here in the third quadrant. So that would be, oh, but we're in degrees. Helps if you do it in degrees. So 30 degrees, sorry. And then 180 plus 30 is 210. And for this one, a cosine of theta equals 3. Don't forget about this. Anything outside of the answers from -1 to 1 are not going to work. So this one is no solution. Now, just because you see something squared, this is where it starts to get a little bit weird. When you see something squared, you kind of assume, oh, Pythagorean identity. But that's not going to be true. Sometimes when things are squared, it's just factoring. So the key is that when you have the word squared and then the same word not squared or not to that power, that's probably factoring. So if you look down here where we have cosine squared, right? So we have cosine squared, and then we don't have cosine. We end up having sine. So this is probably a Pythagorean identity. This is also probably a Pythagorean identity. When you see 2 words, it's probably that. When you see only 1 word, like in problem number 2, it's probably just factoring. So we're going to leave this. So we're going to have 2 tangent theta and tangent theta. This is just a trinomial. If you don't like to factor that trinomial, think of it as this, 2x squared minus x minus 3. That might be a little bit more helpful for you. And then just insert the word tangent or cosine or whatever your word is. So we don't really want to put the 3 out here because that's going to keep us far away from getting the goal of -1 in the middle. So I'm going to put the 3 here and then the 1. So outside we get 2 tangent and then we have 3 tangent, so I want the 3 to be negative. So now we get the tangent of theta, 2 tangent of theta equals 3. So the tangent equals 3 over 2. And here the tangent equals -1. Now we're in degrees. The directions are nice. I tell you nearest tenth, so that's kind of a nice warning that you're going to maybe need the calculator. So this one requires the calculator because 3 over 2 is not on the unit circle. And so you're going to get first quadrant answer is, sorry about that, 56.3 degrees. And then, of course, we'll put that in the third quadrant, add 280, 236.3 degrees. Now, this one is on the unit circle. Obviously, you have your calculator out. If you need it, use it. So it's negative in the second and fourth quadrant, so it's negative 135 degrees and 315. Be careful. If you use the calculator will give you negative 45, and you don't want that. So make sure you answer it correctly. This next problem has this obviously as the domain, and these have a tendency to be a tiny bit harder to think through. Also, please do not divide by sign. We're going to factor this. Don't ever divide by a word. You eliminate your answers that way. I'm going to get this thing set equal to 0. I knew to do that because the words are the same. If the words were different, I'd want to try a Pythagorean identity. So the words are the same, so I'm going to get it set equal to 0 just so I can factor it. So it's the greatest common factor of just sine. So here we get that the sine of x is equal to 0, and that the sine of x is equal to 2. Well, just like the one above it, this one is done. There's no solutions here. But sine being 0, and our domain being the way it is, you got to really think through it. So we know it's 0 and pi. So that's pretty good. But we're allowed to use pi. It's also negative pi, right? Is this spot. This spot just happens to have two names for this domain. So we can use that. Now you can't use 2 pi because that's not in the domain. So even though pi and negative pi are the same location, we have to list them both. Something else that will change now is general solutions. General solutions are kind of gone, but really just replaced with negative infinity to infinity. So rather than going through and doing a whole problem, you obviously can do these, but now when you see negative infinity to infinity, this is when you take your answer and you add the 2 pi k. Please don't do this all the time. Just do it when you see the negative infinity to infinity. So when you see that your domain is all reals, that's when you have to generate all of the answers. And so because there isn't really like a super great pattern here, we can go ahead and just add 2 pi k to every single solution. Sometimes you can find a nice pattern, add 1 pi k or add pi over 2k. So I don't know if you can tell, I'm just trying to get you warmed up for these at the bottom here. Here is where we're going to use the trig identities because we have 2 different words. So put there a little pro tip, try to rewrite so that you have only one trig function. So you have only one word. What word? It's up to you. All right? We've got a lot of options. Remember, the trig identities, Pythagorean identities, require that you have a squared. Right? So we're going to have to work with this. This is the one we can change. We cannot change the 1 minus sign. So if you look at your Pythagorean identity paper, or if you're going to have to recreate that every time, it's easier to look at than to think through. We can see that cosine squared minus 1 is the thing. So I'm going to move the 1 yes. I'm going to move the 1 over. Maybe if I can't get my poop in a group here. So we have cosine squared minus 1 equals negative sine. I want the 1 and the cosine together because when you look at the paper, it should be 1 minus cosine squared. Well, it's not. It's backwards. So this is going to be a penalty of a negative sign. So we have negative sine squared equals negative sine. And I am picky. I like to have my sine squared positive. So I'm going to actually move this over here and put the 0 here. So I'm going to add the sine squared to both sides. So sine squared theta minus sine theta. Of course, that equals 0. These have, of course, a sign in common. We just did this, so it's pretty recognizable. And so now we have that the sine is 0 and that the sine is 1. Well, sine is 0. We just did that. However, we are in degrees. 1 rotation, so this is going to be 0 degrees, which we're allowed to use, and 180 degrees. Oops. Negative 1 is not really what's happening. It's really positive 1, sorry, because that is a negative 1. And so that's obviously straight up, so that's 90. With this one, I'm just going to put it in tangent squared. I mean, you have a choice, but I don't mind working with the tangent. If you hate working with the tangent, switch it to secant squared. Your choice. Completely your choice. I'm going to switch this and get rid of this guy right here. He's coming out. And I'm going to replace it with the Pythagorean identity that says secant squared is tangent squared plus 1. Of course, the equals 3 is still there. Now I have kind of a different situation here. I have 2 of these. So this is 2 tangent squared. And I'm going to subtract the 1 to the other side. This is working out pretty good. I'm going to divide by 2. Tangent squared is now equal to 1. And we're going to take the square root. And we get that the tangent is both positive and negative 1. Now, very serious domain restriction. We are allowed to use 0. We are allowed to use pi. We are in radians. So technically, I guess we're from here to here, if that helps you. Tangent is positive, well, it's positive and negative everywhere, but we're only allowed in the top half. So we don't have a lot of answers. So it's going to be pi over 4. And then in the second quadrant, it would be 3 pi over 4. Here we have to kind of switch this, don't we? So 1 minus secant isn't a thing because it's not secant squared. So I'm going to take out the tangent squared. I don't need the 1. I can just leave this here. So the tangent squared, when you look at the identities, this is secant squared minus 1. Now the other side is 1 minus secant. And now we have the words that match. This will be just regular trinomial factoring. So I'm going to leave the secant squared on this side. I'm going to move the secant over here. So that's going to make it positive secant. And then I'm going to subtract 1. So then I have minus 2. Trinomial. The only way to get 2, obviously, is 2 times 1, and we want that to be positive and this to be negative. So now we have that the secant is equal to 1, which means the cosine equals 1. And here we get that the secant equals negative 2, but that the cosine would be negative 1/2. Both of these have answers. Nice domain that we're used to, right? So 0 to 2 pi, both of these numbers are on the unit circle, so we don't need the calculator. Cosine is negative over here. And so we're looking at pi over 3. So this is 2 pi over 3 and 4 pi over 3. Sorry, I'm looking at the wrong one. I'm doing the next one instead of this one. My fault. I'm not trying to be confusing. So let's go back to cosine equals 1. Sorry. So cosine equals 1, obviously right here where it starts. We're not allowed to use 2 pi, so that's just 0. And then the negative 1/2, this is where I was doing before. Negative 1/2, that's your pi over 3. And so this would be 2 pi over 3, and then 4 pi over 3. So try the problems on the back, and be careful with when you factor versus when you use the Pythagorean identities. Remember, 2 different words. Use your Pythagorean identities. Same word, you're good to go. Factor it.